This is question number 3 for discussion 4. Sorry it's a little bit late, but here you go. So, for the first part of question number 3, they give us a sequence b sub n equals to ln of n over n and tell us to find whether it converges or diverges for any n larger than or equal to 1. So, what we're just going to do here is we're going to find the limit as n approaches infinity of this, because we can represent the sequence as we can represent the nth term of the sequence as a function. And this is our function, right? So we say limit as n approaches infinity of b sub n equals to the limit as n approaches to infinity of L of n over n, right? So if we do n equals to infinity, L of infinity equals to infinity, and then n equals to infinity, infinity over infinity, that's our indeterminate form, so we have to use L'Hopital's rule. And then what we do, we just find the derivative of ln of n, which gives us 1 over n, and then we can find the derivative of n, which is 1, right? And then we bring over here, that's 1 over n over n. I just switched the n to an x to represent it as a function, right? And so I have limit as x approaches infinity of 1 over x. Now what we can just do here is just plug in infinity. We have 1 over infinity, which gets the bottom is growing way, way, way larger than the top. So we have 0. Therefore, it converges because 0 is a finite number. Alright, so for the part 2, it gets a little bit tricky. They tell us to find whether or not this series converges or diverges, right? So, with a series, we're adding up all these terms, right? And as you start to try to figure this out, what you start to notice is that other than this first term, 4, so we're going to kind of exclude that from here. Other than this first term, we see that each nth term is multiplying by, has a denominator multiplying by 4, right? And the top is staying 1. So we have 2 times 4 equals 8, 8 times 4 is 32, 32 times 4 equals 128. So then what we can say is that it has a common ratio of 1 over 4, which when we have a common ratio, it is therefore geometric, right? So the 4 is off by itself, remember? And then we're saying that this has a common ratio of 1 over 4, right? So if this is n equals to 1, so because we're only counting this part of the series in our geometric formula. So if this is our n equals to 1, n equals to 2, n equals 3, n equals to 4, what we can then figure out is that if we do, or matter of fact, we can even use n minus 1, right? So to the power of n minus 1, right? And then what we start to see is that every single time we do it, we get, for example, if this was 2, n equals 2, then we have 1 to the 4th time to the power of 1, which is 1/4, which isn't what we're looking for. But then if we do over here, it's the same thing where it's 1 over 16, and then it's 1 over 64. So, but what we see is that each term that we get when we have the 1 over 4 to n minus 1 is large, the denominator is larger times 2. So what we do is that we want to multiply the whole thing times 2 so that we can bring our denominator down to the value that we want it to be. So, boom, right? But this is how you all find the sum, right? And we're just trying to find out if it diverges or converges. So we use our rule where the absolute value of r has to be less than 1, right? And our r is 1 over 4. 1 over 4 obviously is less than 1, right? So we know it converges, right? Boom, right? And then if this part of the sequence, if this part of the sum of the series converges, right, to a finite number, what we then know is that if we add 4, which is another finite number, to whatever this converges to, another finite number, a finite number plus a finite number is going to equal to a finite number. So I'm just going to say equals to finite because we don't actually have to find the sum of the series, right? So then we can say now that this entire series actually converges. Alright, I hope this helps. It's kind of tricky, but yeah. Hello.